All right, you guys, let's check it out. Let's hit number 11 through 20. Here we go. Okay, so looking at some more derivatives here. We have got the derivative of inverse sine. You guys remember what that is, right? Okay, so it's going to be 1 over the square root of 1 minus x squared. Now, a lot of times when I write this, instead of putting 1 minus x squared, I'll just put the parentheses because this is what's going to go inside of there. Okay? Now, I also have to remember to do a chain rule, so I have to multiply by the derivative of 1 over x. Okay, if you forgot how to do that, let's go ahead and do that on the side here. 1 over x, I can write as x to the negative 1. So the derivative is negative 1x to the negative 2. Or I can go ahead and write that as negative 1 over x squared. Okay? So, how would I simplify this? I would probably put negative 1 on the top, x squared, and then 1 minus, and then if I square that, 1 over x squared. You could maybe simplify more, but I think that that's probably good. I think that's where we'll go ahead and leave that one. Okay? Okay, for number 12, we're going to find the arctan of 2x. All right, the derivative of arctan is 1 over 1 plus x squared. And for that, that's going to be 2x squared. And then for chain rule times 2, right? So that, I'm going to go ahead and put 2x squared is 4x squared. Okay? So when I'm trying to find f prime of 0, I get 2 over 1 plus 4 times 0 squared, which is 2 over 1 plus 0, which is 2. Okay? All right, perfect. Okay, we have an inverse question here. So remember how that goes, all right? I kind of always start at the end. I do these a little bit backwards, so I go, okay, if I'm trying to find g prime of 3, it's going to be 1 over f prime of something. And we got to fill in what number goes with 3. Now, actually, a lot of times on like your AP test, it won't give you this information, which makes it a little bit difficult. I'm going to show you guys how you could get that, but on this test, you would have that information. But let me just show you really quickly, okay? Let's say I didn't have that, right? Well, in order to figure out what g prime of 3, what I have to use is I go like this. I go, okay, g of 3 is something, which means f of something is 3, right? So I kind of like make that little statement off on the side. So I'm like thinking, okay, what is this saying? It's saying, when does this equal 3? Now again, with this note that you will have on your test, we already know that it's going to be 0, and we're going to fill that in. But let's pretend like we didn't have that, okay? Because you guys solve this equation. X squared minus 4x plus 3 equals 3. Well, if I subtract that over, the 3's will go away. X squared minus 4x equals 0. That's a factoring problem, all right? But it's just a GCF. I can take out an x. And then for my solutions, I get x equals 0 and 4. Now, why did we pick 0? Well, that's why they had to say that, right? X is only numbers less than or equal to 2, so 4 is not going to work, so I'm going to get rid of that. So it's 0. Okay? Now again, if it just tells me f of 0 is 3, 0, 3, 3, 0. Okay? At that point, I come over here. If that's 3, that's 0, and now I go to work. All right, this is telling me to find f prime of 0. So here's my equation. Let's go down here. F prime of x is 2x minus 4. Okay, let's go ahead and find out then what is f prime of 0. So it's 2 times 0 minus 4, which is negative 4. And so my answer would be 1 over negative 4. All right. Cool, cool. Here's another one. Inverse. Now it's using f inverse of f, but h is f inverse. This is very confusing. All right. So basically, you guys, I have f and h. We're just going to go with f and h, right? And it's looking for what is h prime of negative 7. Well, it's going to be 1 over f prime of something. Okay, so how do I find that something? Again, with this information, it just tells you, right? Notice the point 1, -7 is on the graph of f. Okay, so that means f of 1 is -7, which means h of -7 is 1, and that'll put a 1 right there. All right. Again, it wouldn't be that necessarily like difficult to solve this. You know, if you didn't have that little hint right there, let's say that that wasn't there, well, I'd have to find out, okay, what number does f equal -7? So if I add that over, x to the third is 1, so x is 1. So it's the point 1 that gives me -7, and -7 gives me 1. Okay, so regardless, so we went ahead and found that. Now, h prime of -7 is 1 over f prime of 1. Let's go ahead and find the derivative here. F prime of x is 3x squared. If I plug in 1, I get 3 times 1 squared, which is 3 for f prime of 1. So my answer is going to be 1 over 3. All right. Here's another inverse question. G is the inverse of f. Here we go. G prime of 2 is 1 over f prime of something. And I don't know what that number is. Now, this one did not give me a hint. Okay? That's okay. That's okay, right? So I'm going to come over here and I'm going to say, okay, well, g of 2 equals something, which means f of something equals 2. Right? So we start with g of 2 equals something, which means f of something equals 2. So let's come up here. Where does this equal 2? Well, if I add that over, 3x equals 7, x equals 7/3. Well, that's the most annoying thing ever. Okay. All right, so g prime of 2 is 1 over f prime of 7/3, right? Now, what's f prime of x? What's the derivative of 3x minus 5? 3. So f prime of 7/3 is 3. So actually, I didn't actually really even need to do that, did I? I didn't really need to do that because, well, the derivative of f was 3 no matter what we plugged in. But it still kind of shows you how to go through the process, okay? All right, moving right along here. Let's look at number 16, aka number 8, but really number 16. Okay. All right, here we go. The function given by h of x is that, and h of 1 is 2, h inverse is the inverse. Okay. Again, if you don't love the like h inverse prime, you know, use a different letter. But I always start at the end, and I go like this. Okay, so h inverse prime of 2 is 1 over h prime of whatever goes with 2, and that's right here, right? Okay, so if h of 1 is 2, h inverse of 2 is 1. All right, and then I just need to find the derivative of this. So that's cool. The derivative of h is 5x to the 4th plus 3. Over a little bit. And now when I try to evaluate that at 1, 5 times 1 to the 4th plus 3. 5 plus 3 is 8. So I get 1 over 8. Okay? Hopefully these inverse questions, like once you kind of get the hang of it, they're actually pretty simple. They go pretty quickly. Okay. Okay, cool. Let's look at number 17, not 9. Okay. Let f of x be that g is the inverse, blah, blah, blah. Okay, here we go. What is g prime of 1? G prime of 1 is 1 over f prime of something. Okay? Well, the something is right over here. If f of 0 is 1, g of 1 is 0. All right? And let's go ahead and find the derivative now. Okay, so if I come over here, you guys, this is a chain rule, right? This is a chain rule where we do the 3 comes down in front, squared, times the derivative of the inside, because a chain rule I need to multiply by 2. So it's actually 6 times 2x plus 1 squared. If I'm trying to find f prime of 0, 2 times 0 plus 1 is 1. 1 squared is 1, so that equals 6. So look, my final answer is 1 over 6. Okay? All right, that was good. A lot of good inverse questions there. Okay, here's an implicit question. Given the curve, consider the curve given by the equation y to the third minus xy equals 2. It can be shown that dy dx is that. Great. All right. Write an equation of the tangent line. All right, you guys know how to do that. Let me get a little space right here. Y minus, this is x1, y1. Y minus y1 equals m x minus x1. Okay? All right, so that's going to be plus. The only thing I really need to find is m. Well, m is dy dx. So when I come up here to find that, if I plug in 1 for y, and I plug in -1 for x, I end up getting 1 over 4. Okay? All right, so that is my equation of the tangent line. Perfect. All right. For part B, so this is more of like a free response type question, right? Find all the coordinates of points on the curve where the tangent line is vertical. Okay, let's talk about this for a second. All right, you guys, when you're doing, let me just write this down somewhere so you could take notes. My goodness, this is long, and it doesn't even have any room at the end. All right, here we go. If you are looking for a horizontal tangent line, that is where the slope is 0. If you are looking for a vertical tangent line, that is where the slope is undefined. Now, let's say, usually with these kind of problems, you guys were looking at rational functions, which is basically like f over g, something like that. Okay? Listen, if you're trying to find out where a fraction is equal to 0, that's where the top equals 0. That will give me a horizontal because 0 divided by anything is 0. If I'm trying to find a vertical, it's where we set the bottom equal to 0 because a number divided by 0 is undefined. So horizontal is when the top is 0, vertical is when the bottom is 0. Okay, so this particular question, get back up here, asked me for, here we go. There we go. Okay, this question asked me to find all the points where the line tangent is vertical, bottom equals 0. Okay? So if I solve that, it's going to be all the points on the curve where 3y squared equals x. All right? But the points have to be on the curve. So now I'm going to take that, and I'm going to put that into here, probably for x, right? Because I solved that for x. So vertical tangent line is going to be where the bottom equals 0. So let me go ahead and go put that on the curve. So this is going to be y to the third minus, now this says 3y squared, that's what I'm going to put in for x, times y equals 2. Y to the third minus 3y to the third equals 2. Well, 1y to the third minus 3y to the third is negative 2y to the third. If I divide, y to the third is negative 1, which means it's the point where y equals negative 1. Now, what's kind of cool is that I can actually, to find the x value, I could sub into either that equation right there, or my original equation right there. Okay? Well, obviously, this one's a little bit easier. When y is negative 1, x should be 3. Let me just see if it works up here, though. if y is -1, okay, -1 to the third is -1. Negative times negative is plus x equals 2. And then if I add that over, x equals 3. So you can go into the derivative or you can go into the, original function. Either case will get the point. 3, -1. All right, so it says to find all of them. Well, this is the only one. So the only point is 3, -1. Wouldn't it be helpful if we could kind of visualize what we're doing, right? So again, this has like nothing to do with unnecessarily like what's on your test, but it's kind of good to just understand. Okay, so my equation was, sorry, let me go back to it really quickly. My original problem, y to the third minus xy equals 2. Y to the third, right, minus xy equals 2. Okay, cool. Can we see, this is a super weird graph, all right. Can you guys see where that graph has a vertical tangent? Does it kind of look like right over here, like at the point 3, -1? Because right there is where it's going to have a straight up and down vertical tangent line. All right? So that was kind of cool. Okay. Now the third part, part C, really did not give you enough room on this one. Evaluate the second derivative where x is -1, y is 1. Okay, cool. I already have the first derivative, right? So let's do a second derivative. Maybe I'll write this one over here just so I can see it a little better. Y over 3y squared minus x. Okay. We're going to do a quotient rule, right? Okay, derivative of the top times the bottom minus the top times derivative of the bottom. Now this is going to be 6y dy dx minus 1 all over the bottom squared. Okay? My goodness, this sucks. All right. Now, we're trying to evaluate it at, check it out, x is -1, y is 1. I'm going to write these over here. X is -1, y is 1. And let's figure out really quick what dy dx equals. Well, if y is 1 and x is -1, this equals 1 over 4. Oh, we already did that in the first part, but that's cool. Okay, so dy dx is 1/4. So at this point, you guys, I'm just going to start plugging everything in, all right? Okay, that's 1/4. Y is 1, x is -1. Okay, so this is, I'm going to move over here, 1/4, 3 times 1, 3 minus -1. And then y is 1, so that's 6 times 1/4. Actually, I'm just going to go ahead and write 6/4 minus 1 over, if that's 1 and that's -1, that's 3 minus -1 over 4 squared. Ooh, that is terrible. All right. 1/4 of 4 is 1. I'm going to go to decimals because I can't right now. Okay. 6/4 is 1.5 minus 1 is 0.5 times 1 is 1/2. So it's basically 1/2 over 16, which then goes to 1 over 32. There we go. All right. That's kind of like a, what was I saying, like a free response type question. Okay. It takes like a lot of different steps to go through that. Okay. That one was tricky, but hopefully you guys are. Okay. So what's that saying? Well, it's saying that at the point -1, +1. So looking at this graph, again, just to kind of see what we're talking about. What I say was -1, comma, +1. Okay, at that point right there, the slope is 1/32. Okay? And you can see how my, like if I had this in a if I had this in a standard graph, you could see it's very, up 1 over 32 or something. All right, that's what my slope would be right then. Cool. Okay. Let's move this out of the way for a bit. Okay, let's do a couple more questions here. All right. For number 19, we have a twice differentiable function that satisfies the conditions below. So first, second, third, or sorry, f of x, the first derivative of f, the second derivative of x, okay? Let g equal 3 sine 2x plus f. Let h equal e to the f. This looks like another free response question, yeah? Okay, find g of 0. Now, you guys, this just means plug in 0. Let's do different color here. This just means plug in 0 here and here. So g of 0 would be 3 times the sine of 0 plus f of 0. Well, if I go look at my best friend trig chart, I know sine of 0 is 0, and then f of 0 is 5. So 0 plus 5 is 5. Okay? Now I got to find g prime of 0. Well, let's find the derivative of g. Let me actually write it up here. Okay, it's going to be 3. Derivative of sine is cosine of 2x times 2. And then f prime. All right? Well, at 0, it will be 3. It will be the cosine of 0 times 2. And then it'll be f prime of 0. Okay, you guys, the cosine of 0 is 1 from your chart. That's 1. 3 times 1 times 2 is 6. F prime of 0 is 3. So that one is going to equal 9. Okay, next I'm going to do h prime of 3. All right, let me figure these out down here. If it's e to the f of x, the derivative will be e to the f of x times f prime of x. All right. So h prime of 3 would be e to the f of 3 times f prime of 3. Well, e to the f of 3 is 0. And then this is times. F prime of 3 is 2. So 1 times 2 is 2. All right? Not too bad so far. This next one's a little bad. I'm just warning you. All right. Because guess what I have to do? A product rule. Here we go. Derivative of the first times the second plus the first times derivative of the second. Well, the derivative of a 1 prime is a 2 prime. Okay, so there's my product rule. Hopefully you guys are okay with that. The only thing that I have to go back and kind of think about is derivative of the first. Well, the derivative of e to the f of x is e to the f of x times f prime of x. That whole thing is another chain rule. So it's e to the f times f prime. That's derivative of the first times the second. That's another f prime. And then first derivative of the second. Okay? At 3. So it's going to be e to the f of 3, 0, times f prime of 3 times f prime of 3 again. And then e to the f of 3, e to the 0, and f double prime of 3 times 4. So e to the 0 is 1. 1 times 2 times 2. 1 times 4. 4 plus 4 is 8. How fun was that? That was so fun, Ms. Mitchell. Thank you, students. All right, here we go. Write an equation of the tangent line. Oh, I'm going to stop what I'm doing, and I'm going to put, for part E, y minus y1 equals mx minus x1 at x equals 0. Cool. So x1 is 0, so what's y1? Well, it says it's the graph of g. G of 0 is 5. That came from part A. Okay, m is the derivative at 0. What's g prime of 0? Ooh, that comes from right there, 9. Oh, that's so beautiful. We didn't actually have to do that much more work. Y minus 5 equals 9x minus 0. Love that for us. Okay? And here we go with number 20, and then we will take a break to do our next 20. Here we go. Oh, I'm so sorry. These are like copies of copies of copies. Let's see if I can write this a little better. Xy squared minus x to the third y equals 6. Show that. Okay, I could do that. So if I'm showing this, I'm going to do a couple of product rules. With this product rule, I'm going to include the negative, right? So for part A, okay, derivative of the first times the second. First times derivative of the second. And then derivative of the first second. First derivative of the second equals 0. You guys remember we talked about this. Anything with a dy dx, I'm going to go ahead and keep on this side. Anything without a dy dx, I'm going to send to the other side. And when I send it to the other side, it's going to switch signs. So this will be minus y squared and plus 3xy squared. And then on this side, okay, so that's gone. That's gone. I moved it to the other side, right? On this side, I factor out a dy dx. So I have x times 2y minus x to the third. And then that's what I divide over. And so that's my answer, which matches up to that. The terms are like a slightly out of order. Okay? Beautiful. Find all the points on the curve. So I'm going back to the curve, the original problem, where x is 1. All the points on the curve where x is 1. And we'll do whatever we need to do in just a second. But for right now, let's find all the points where the x-coordinate is 1. Okay, so it would be 1y squared minus 1y equals 6. That definitely looks like something I can solve. In fact, I can solve that by factoring y minus 3, y plus 2 equals 0. So y is 3 and negative 2. So the points on the curve, now remember, this is where the x-coordinate is 1. So there's actually two different points here for part B. The point 1, 3, and negative, and 1, negative 2. Because x is 1, y is 3, x is 1, y is negative 2. So that's my answer for part B. Okay? Find, and then, oh, nope, I need to keep going. Write the equation for the tangent line at each of these points. Okay, why is this question so very long? Here we go. For this point, it would be y minus 3 equals something x minus 1. For this one, it would be y minus negative 2 equals something x minus 1. The way I would find the somethings is I would plug in 1, 3, and 1, negative 2. Okay? So let's do that. I'm majorly running out of room here. Into the derivative, I'm going to go ahead and plug in 1, 3. Let's see here. When x is 1 and y is 3 and x is 1 and y is 3, I get 9 minus 9 over, doesn't really matter, but I'll finish it anyways, 6 minus 1. So I get 0 over 5, so I get 0. Okay? For the other equation, or sorry, for the other point, which is 1, negative 2, my goodness, 1, negative 2, 1, negative 2. Okay, I get negative 6 minus 4, and then negative 4 minus 1. So I get negative 10 over negative 5, which is positive 2. Those are my two equations of the tangent line. Whew! My brain's about to explode. How about you guys? Find the x-coordinate of each point on the curve where the tangent line is vertical. Okay. A tangent line being vertical means that the bottom equals 0. All right? So it's going to be all the coordinates on the point where that equals 0. Find all the coordinates of the point. Find the x-coordinate where the tangent line is vertical. If I divide by x right here, I get all the points where 2y equals x squared. Then I can come back up here, plug this in, okay, and go ahead and solve that. Let's see. Okay, if we have... This recording is getting very long. I'm going to stop it here, and we're going to finish this in 1 second, because it's just got 30 minutes.